Okay, so now we're going to get to some actual polynomial multiplication. So these are going to be more like what you guys are seeing. And just to give you guys a heads up, and just to be honest with you guys, there is a lot of work that you are going to have to show on these types of problems to get the final answer. Okay? Because just like with our simplification, before I can look to cancel anything, I have to factor. Remember, if you try to do something where you cancel x squareds like that, you will be killing kittens. And I would advise you guys not killing a kitten. Okay? So, we want to make sure that we factor first. And what that means is, I have 4 different problems that I need to factor. Okay? So there are 4 different areas that we have to try and factor for this problem here. So starting out with, I've got a 5x squared minus 15x. It doesn't have our 3 terms, so we can't factor like what we normally would. The first thing that I have to do is there anything in common? Well, I've got a 5 and I've got an x. Now that x is squared, minus a 15 and an x. So what do they have in common? Well, they both have an x in common. Do they have anything else, though? Well, I have a 5 here. Now, 15 is just another way to have a 3 times a 5x. Okay? So the way we can look at that and see, oh, they have a 5 and an x in common. So if I pull out that 5 and that x, I still have 1x because there was an x squared there, and I've got a minus 3. Okay? A lot of you guys are probably just going to look at this original, see 5 and 15. Oh, those both have a 5 in common. I pull that out. An x and an x, they both have an x in common. I pull that out. Okay? So, top left, I've got 5x, parentheses, x minus 3. Now, top right, I've got x squared minus 5x plus 6. Okay? I need factors of 6 that will add to give me 5. 1 and 6 do not add to give me 5, but 2 and 3 do add to give me 5. So x squared minus 2x minus 3x plus 6. I know that they both need to be minus signs because if you've got a plus sign there, they have to have the same sign, and we need it to be a negative 5. Okay? I can pull an x out, leaves me with an x minus 2. I can pull out a negative 3, leaves me with an x minus 2. So I get x minus 3 times x minus 2. Okay? So up in my top right, I have x minus 3 times x minus 2. Okay? I would, if I was you guys, use the margins of your paper to write out these next ones. I don't have those margins here, so I'm going to have to erase them. Next, I have an x squared minus 4. X squared minus 4 is one that some of you guys might look at and just say it's x plus 2, x minus 2, and that's great if you've started to recognize that. Some of you guys will not. You just need to remember it's an x squared plus 0x minus 4. So 1 times 4, factors of 4 that subtract to give me 0. Well, 2 minus 2 would give me 0. Since this is a minus sign, I need 1 to be a plus and 1 to be a minus. I can pull an x out, which leaves me with an x minus 2. I can pull out a positive 2, which leaves me with an x minus 2. So I get x plus 2 times x minus 2. Okay? And then last we have the bottom right. And the bottom right is x squared minus 6x plus 9. 1 times 9, factors of 9 that add to give me 6, would be 3x and 3x. It's a plus sign, so their signs need to be the same, and they both end up needing to be negative. Pull out an x. Pull out a negative 3, which will change that sign in the middle. So my two factors are x minus 3 and x minus 3. So, again, the first thing that I have to do is factor everything so that I can avoid killing any kittens. Now, can I cancel anything diagonally? Well, from my top left to my top right, they both have an x minus 3. So those will cancel. From my bottom left to my bottom right, or my bottom left to my top right, they both have an x minus 2. So those will cancel. After I do that, I'm left with a 5x over an x plus 2 times an x minus 3 over an x minus 3. Okay? Is there anything vertically that I can cancel here? Well, yes. X minus 3 and x minus 3. So I've essentially canceled everything from that fraction. All that I have left is 1 and 1. So 5x times 1 is just 5x. X plus 2 times 1 is just x plus 2. And that's my answer. So, important things to remember. Factor everything. Okay? Factor everything. Cancel diagonally, then we can cancel vertically, and then we just multiply straight across. Division. There is one more step before we factor everything. And the one more step before we factor everything is we have to flip the second fraction. Okay, we change it to multiplication and flip the second fraction. So this is x squared plus 2x times x cubed plus 7x squared plus 10x over 2x minus 1. Okay? Now, as far as factoring goes, 1 is already factored. 2x minus 1 is already factored. Okay? X squared plus 2x, I don't even need to show any work on this one. The only thing that I can do on factoring that is to pull out an x. Okay? Now, the x cubed plus 7x plus 10x, that one's going to have a couple of steps that we're going to need to do on that. The first thing is, if you notice, all three of those terms up there have an x in it. So this could be an x squared plus 7x plus 10. Okay? So the first thing I did on the top right is I just factored out the x from all of them. Now I'm going to take my 1 times 10, and I need factors of 10 that will add to give me 7. So that's x squared, 2x, and 5x plus 10. Okay? And since that's a plus sign, they both have to have the same sign. We need them both to be positive, so it'll be a plus 7x. I can pull out an x from the first two. I can pull out a positive 5 from the next two. And I end up with x plus 2 times x plus 5. Okay? Now, the only thing you don't want to forget on this is, remember at the very beginning we pulled an x out. So I'm just going back through and adding that x on the outside. So top right we have x times x plus 2. Well, I wrote x plus 5. We also have an x plus 5. Okay? So again, first we have to flip the second fraction. Factor everything. You have to factor everything. Okay? Diagonally, 1 and 2x minus 1. Can I cancel those 1s? No, because that 1 is part of a term. That would be killing a kitten. We cannot cancel terms. We can only cancel whole factors. So x plus 2 and x plus 2 you can cancel. Can I cancel those x's? Some of you guys will say, well, that looks like a term to me, but that is x times x plus 5. So that x is just a factor. I can cancel that x, and I can cancel that x. So I've only got a 1 left on this side, and an x plus 5 left on the other. There's nothing else that I can cancel. 1 times x plus 5 gives me x plus 5. And then 1 times 2x minus 1 gives me 2x minus 1. And that's our answer. Okay? The only other thing we have is complex fractions. And you guys are going to look at this. This is a complex fraction. You guys are going to be, what the heck is that? Okay? Well, fractions are just division problems. If I ask you guys what is 40 over 5, all I'm asking you is what is 40 divided by 5. Okay? So when you see a complex fraction, you have this fraction here divided by this fraction here. So I have an a squared minus b squared over b cubed divided by ab squared minus ab over a squared. So the first thing that you guys should do when you see a complex fraction like this is rewrite it as a division problem. And now it's just like the problem that we were doing on the last slide. Okay? So I need to change every division problem into multiplication. So I'll make that multiplied by, and now I flip the second fraction. Okay? And then I'm just going to look to factor if I can. Okay? So as I look on this, I've got an a squared minus b squared. We don't see a lot of those, but that is just the same thing as the difference of squares there. A is squared, b is squared. So that becomes an a plus b times an a minus b. Bottom is still just b cubed. Okay? Times an a squared up top. And then the only thing I can do on the bottom right is both of those have a b. So I can pull a b out in front, and that will leave me with a b minus a. So, simple enough there. I have a b minus an a though, and up top I have an a minus a b. So those are actually kind of opposites of each other, because my a is negative and my b is negative there. So the only thing I can do on that, and there won't be one like this on your test, which is why I put this one in here with us in the notes. If I wanted to, I could pull out a -1, because pulling out a -1 always changes the signs. So that would now make that a negative a plus b, which I could rewrite as a b minus a. And then that will make it cancel. You won't have to do one like that on your homework. I just wanted to show you guys that there. So this a minus b, I am changing it to a -1 times b minus a so that I can cancel. So that gives me an a plus b. Now I have a b minus a and that -1 over b cubed times a squared over b times b minus a. Now my b's minus a's will cancel. A squared, no. B, there's nothing diagonally that will cancel. So my final answer for this, I'm going to have to write it over here because I ran out of room, is negative a plus b times an a squared. So typically when we have that, we'll just put the a squared out in front. So a plus b, negative a squared times a plus b. In the bottom you have a b cubed and just a b. So we have a b to the fourth. Is there anything else that can cancel? No, I can't cancel those b's because that's a plus b, so that b is part of a term there. So that's just our final answer. Okay, so complex fractions, they look complex, but just remember your complex fractions are just simply a division problem, and we know that for division problems, we change it to multiplication, and we flip the second fraction. Okay, so we will be practicing this next class time.